Hello, everybody. So we are continuing with our first learning target for this chapter, which is finding the domain and the range. We're in the middle of a tough one, which is finding those things algebraically. Remember, there's two basic rules. You can't take the square root of a negative, and you cannot divide by 0. Those are real strong guidelines in finding the domain. And the domain is the set of all x values. Today, we're going to actually include the range. And remember, no calculator, no graph. Our first example here is f of x is 3x divided by x squared minus 9. Well, I'm not taking the square root of anything, but I am dividing by x squared minus 9. And x squared minus 9 is the same as x minus 3 times x plus 3. So there are two numbers that make me divide by 0, positive 3 and negative 3. If x were either one of those numbers, I would be divided by 0, and that would be impossible. So my domain is every x value except 3 and negative 3. Now, how do you express that as an interval? Well, imagine the number line spanning all the way to the left and all the way to the right. Every number is included in this domain except for negative 3 and positive 3. So that splits the number line into 3 distinct intervals. Every number less than negative 3, every number greater than 3, and every number in between negative 3 and 3. What about the range? Well, here's a different example for the range. Now, the range here is, this is a rational function, which has a specific end behavior. Remember end behavior from Algebra 2, I hope you do. There's a vertical asymptote here of x equals negative 5, vertical asymptote. But we want to know the horizontal asymptote. What happens when x gets very, very large? That helps us understand the horizontal asymptote. When x gets very large, or same argument as when x gets really small. So when x gets really large, you're looking to the right on the graph, way to the right. When x is 1,000,000 or 1,000,000,000. Well, 1,000,000 plus 5 is 1,000,005. And negative 9 divided by 1,000,005 is essentially what? What's negative 9 divided by a very, very large number? It is essentially 0. So this fraction right here, negative 9 divided by x plus 5, when x gets really, really big or really, really small. So in other words, way to the right or way to the left, this whole fraction is approaching 0 because it's negative 9 divided by a really big number or a really, really small negative number. But then you add that 0 to 4, and you discover that g of x, this function, has a horizontal asymptote of y equals 4. And that is the number that is excluded in our range. This function will produce every y value except for 4. So imagine again the number line, and it's every y value except for 4. So everything less than 4 and everything greater than 4. And here's the algebra behind it, which is going to be convincing to some. This on the right of the equation is g of x, remember? And I want g of x to equal 4. Let's just try to force it. Let's just say, what would happen if I set this equal to 4? You get a contradiction is what happens. To solve for x, you would subtract 4 on both sides, making this 0. And then you would multiply both sides by x plus 5. And 0 times x plus 5 is 0. And you end up with 0 equals negative 9, which is a contradiction. So in other words, g of x can never equal 4, which means 4 is not in the range, which is why the answer is this set of intervals. Next, without a calculator and a graph, what is the domain and range of this? Well, you're not dividing anything, but you are taking the square root of something. And this something cannot be negative. So right away, 6 minus x cannot be negative, which means it could be 0 or it could be positive. To express that mathematically, you would say 6 minus x is greater than or equal to 0, which is the same thing as saying 6 minus x has to be either 0 or positive. It can't be negative. Subtract 6 on both sides, divide by -1. I hope you remembered to switch the sign if you divide by a negative. So we discover that x must be less than or equal to 6. That is the domain. As long as x is less than or equal to 6, then this function will produce real numbers. It only exists to the left of 6. What about the range? Well, if you're good with transformations, finding the range is going to be, and the domain for that matter, it's going to give you an advantage. What are the transformations here? Well, the parent function, it's a square root function. And it was moved to the right 6 spots. This negative flips it over, the 3 stretches it, and the -5 drops it down. We'll practice more on transformations in a couple of days. But for right now, the domain could help us also. I know that the biggest number this function could ever receive is 6. So let's see, what does this function produce when x is 6? When x is 6, I get -5. So -5 is a range value. What about, and then the domain continues, it's less than 6. So what about 5? If x is 5, then my range output is -2. So that's my second range value. Let's pick another domain element, but let's be smart, because I know I don't have a calculator. So I don't want to choose 3 for x, because 6 minus 3 is 3, and I don't want to figure out the square root of 3 without a calculator. So I'll be smart and choose 2 for x. 6 minus 2 is 4. And the square root of 4 is 2. So this is 3 times 2, which is 6, and 6 minus 5 is 1. And now look at the domain value started with 6, my biggest possible domain, and I just went smaller and smaller. And my range values began at -5, and my range values are getting bigger and bigger. So this leads me to a conclusion that the range begins at -5 and just increases from that spot. So the range is -5 to infinity. Here is the graph. The red graph is the parent function of the square root function. The blue graph is g of x for our example. It's to the right 6. It's up 5. Wait a second, was the original -5? Yeah, the original was -5. Let me change that. And so graphically, it's much easier. It's a much easier task. We can see that the range begins at -5 and goes up from there. All right, let's continue. Last problem. This is a great problem. Great problem. You got the square root of this monster. I hope right away you're thinking, square root, the thing inside here cannot be negative. The range is actually easier to figure out here. The range is f of x. And f of x is the square root of this thing. So whatever the square root of this is, for every possible x value, that's what the range will be. The range is the product, it's the result. Well, we know that we can only take the square root of positive numbers, which will give us a positive number. The square root of any positive results in a positive. There's a chance that this thing, x cubed plus 5x squared minus 4x minus 20, there's a chance that it could be 0, but the square root of 0 is 0. So no matter what the x value is for this function, as long as it's in the domain, when I take the square root of that, the result is either going to be a positive number or it's going to be 0. So the range is just everything from 0 on up, from 0 to infinity. The domain is the more the challenging one, but I believe it's easier than the last couple of examples. That's 10 minutes, guys. Please, this is our last example, so please turn the screen off and walk away for a minute and come back. Okay, so I hope you took a little break for yourself. So let's continue here. What I'm going to do is I'm going to think about this polynomial, this x cubed polynomial, and try to figure out when is this polynomial non-negative. And you need your algebra 2 skills here. It is factorable, thank goodness. We got 4 terms here, so I'm going to factor by grouping. These two have an x squared in common. These two have a -4 in common. So I factor those out. Now, this group on the left and this group on the right both have an x plus 5 in common. So I factor that out. And I'm left with 2 factors, x plus 5 and x squared minus 4. But wait, x squared minus 4 is a difference of squares. So that factors into x minus 2 times x plus 2. Wow. So I've got a cubic. It's the square root of a cubic. So this cubic has 3 zeros, -5, +2, and -2. Those are the 3 x values that make this thing 0. How does that even help us? Now, what I want you to do is imagine, back in Algebra 2, you were asked to do this. You were asked to graph this, sketch a graph. You know some valuable things. You know the zeros. You know exactly where this is going to hit the x-axis, -5, -2, and 2. You know how many turning points it has. It's a 3rd degree, so it has at most 2 turning points. You know the y-intercept, -20. And since it's a leading coefficient is positive, it's going to end up going to the upper right. So imagine in your head a cubic. Don't worry about the square root right now. Just imagine in your head the cubic polynomial. It ends up going up to the right because it's a positive positive leading coefficient. Put a little dot at -20 on the y-axis, and then put 3 dots on the x-axis, -5, -2, and +2, and draw your curves to go through those 3 zeros, go through the y-intercept, and then end up shooting up to the right. Hopefully you sketched something resembling this. Notice this cubic function is hitting at -20, and you've got the 3 x-intercepts, one at -5, one at -2, and one at +2. This is the graph of the polynomial, but the function we're dealing with is the square root of this polynomial. And I can't take the square root of negatives. So all these negative values down here are not going to be included. I need to exclude the x values that produce these negative y values. So I'm getting rid of these x values. All the x values from between -2 and +2, they're out because they produce negative y values. And every x value less than -5 is out because it produces negative y values. So my domain is everything between -5 and -2, and everything greater than +2. Which is this set of intervals. I hope that's clear. The only homework today is to just get caught up on your homework that was assigned last week. A quiz is coming up. I'll get a due date on that soon, and we will talk to you soon.